Today we're going to continue graphing absolute value equations. Yesterday we saw what the basic parent function, y equals absolute value, looks like. Remember, it's a V shape. It is symmetric, so when we fold that graph in half, the two sides of the V should match up perfect. Yesterday we reflected our graph. We stretched it, which made it skinnier. We compressed it, which made it wider. Today we're going to keep building on that. Now we're going to start moving our graph around a little bit. Just like yesterday, to make things a little quicker and easier, we are going to use the graphing calculators. Keep in mind, graphing calculators, you can use them on your test. You will still have to sketch the graph by hand. So let's take a look at our first equation. We have y equals the absolute value of x minus 3. Let's go to our calculators and see what this graph will look like. Remember, in order to graph absolute value, we go to y equals. I'm going to clear everything out from yesterday so we have a fresh start and we can once again review how we can graph absolute value with our calculator, where we find everything we need. So please make sure, press y equals. It's in that upper left-hand corner. It's highlighted in red on the screen right now on my calculator. Make sure your screen looks like mine. All the y equals are cleared out, and all the plots up at the top are not highlighted. If any plots are highlighted, arrow up, put your cursor on that plot, and press enter. Now make sure your cursor is to the right of y1 and the equal sign, just like it is on my screen. We want to graph absolute value of x minus 2. To get the absolute value, we press the math key, arrow over to num, and we want ABS. Absolute value is abbreviated ABS, and we press enter. Remember, we talked yesterday, some of you will have a screen that looks like mine with the actual absolute value bars. Some of you will have ABS with a parenthesis. If you have ABS with a parenthesis, the parentheses will act as your absolute value bars. So inside those absolute value bars, we want x minus 2. The x key is next to the alpha key. It's highlighted in red on my screen right now. And then we want to make sure we use the subtraction key. Some of us were getting the subtraction and negative mixed up yesterday. The subtraction key is in that right-hand column. It's highlighted in red on my screen right now. The negative sign has the parentheses around it next to the enter key. And then we just want to type 2. If you have ABS on your calculator with parentheses, you need to make sure you close your parentheses. The parenthesis keys are up above the 8 and the 9. So make sure you close your parentheses. The parentheses act as your absolute value bars. All right, so now we have y equals absolute value of x minus 2. Just to make sure that our viewing window for our graph is okay, let's press zoom. And then just like yesterday, we're going to press number 6 for that standard window. So let's see what happens when we subtract our 2. We still see that nice V shape. It is still symmetric, even though it looks a little different, because now it has moved to the right 2. So when we subtracted the 2, let's go back to our packets. And oops, I'm sorry, it should have been a 3. Let's go back to the calculator real quick. I thought it was a minus 2. Sorry, guys. Go to our y equals. It should be a minus 3. You're probably watching this video thinking, Miss Golly, I know it's a 3. What are you talking about with a 2? There we go. Let's make it a 3. So by making that a 3, and again to change that, sorry, I probably did that kind of quick. Go to your y equals. Put your cursor on top of your 2, put your cursor on top of the 2, and make it a 3. Go ahead and press graph. And we see our graph has shifted 1, 2, 3 places to the right. That vertex point is now 3 places to the right. So if we go back to our packet, now that we graphed the right equation, the vertex point has gone to the right 3. 1, 2, 3. That ordered pair is 3, 0. Whenever you're asked for the vertex, it's always written as an ordered pair. It is a point on your graph. It's the point where the two sides of the V come together. Now the slope piece. Yesterday we were finding the slope of the right side, and we were looking for a number in front of the absolute value bars. We had slopes of 2/3 and 3 and -2. If there's no number in front of those absolute value bars, what number could we put there? We could really put a 1 there. So if there's not a number in front of the absolute value bars like we saw yesterday, the slope of the right side is just going to be 1. If you need to put it over 1, you sure can. The axis of symmetry, we saw that yesterday. That's that imaginary vertical line. So we just draw it dotted. It helps us graph. It's that imaginary vertical line. It goes through our vertex. It splits our graph in half. If we fold our graph in half on that vertical line, the two sides should match perfect. Yesterday, our axis of symmetry was always x equals 0. Now that our graph has been moved, it's not going to be 0 anymore. It is a vertical line, so it still stays x equals. Anytime we've graphed vertical lines this trimester, it's always been x equals to give us a vertical line. But now we have to stop and think about what x does equal on that vertical line. Any ordered pair I pick along that vertical line, the x has a value of 3. Please also note the x value of the vertex should match the x value of the axis of symmetry. X value of the vertex should match the x value of the axis of symmetry. All right, we've got everything we need now to finish our graph. We've got our vertex, we've got our axis of symmetry, we have our slope of the right side. So I start at the vertex, I go up 1, right 1, up 1, right 1. And you can do that a couple times, 2 or 3 times. And then remember, we use that symmetric property and we reflect those points over the axis of symmetry. Draw in the 2 straight sides. This should be a V shape, it shouldn't be curvy. So what happens to the graph when there's a number subtracted from x inside the absolute value bars? Our graph moves to the right. Our graph moves to the right. Now I know it might be opposite of what you're thinking. We did subtract, but our graph still does move right. We subtracted and we did move right. We saw it, we graphed it, we saw it with our own eyes that the graph moved to the right. So this isn't you just taking my word for it. This is you actually seeing it. We just graphed it on the calculator. So we saw that subtracting inside the absolute value bars moved our graph to the right. Now let's see what happens if we add 2. So we have y equals the absolute value of x plus 2. I'm hoping you're already starting to think of what it might do. Probably have a pretty good guess at this point. So let's go ahead, let's go to the calculator. Let's get some practice with these. Whenever I want to graph something, I have to go to y equals. And we have our absolute value of x minus 3 already in there. We can just overwrite that. We now want a plus 2 instead of a minus 3. So if we put our cursor on the subtraction, we hit the plus sign and then a 2. And we should be ready to graph. So whenever you're ready, go ahead and press graph. Think about what you think that graph might do. Subtracting 3 went to the right. Adding 2, our graph moves to the left. Our graph moves to the left. Now again, we saw it. This isn't just me telling you, here's what should happen or here's what does happen. You actually saw it. We put the equation in. We're looking at the graph right now. So let's go ahead and transfer this information over to our sheet. We went to the left 2. That's our new vertex point. So that vertex point is -2, 0. The slope piece, we don't have a number in front of those absolute value bars. You can put a 1 there if you need to help you find that slope. Axis of symmetry. Axis of symmetry goes through that vertex point. It cuts my graph in half. If I fold my graph in half along that axis of symmetry, the two sides should match up perfect. Axis of symmetry is a vertical line. So it's going to be x equals. And we have to stop and think what all the x coordinates would be along that vertical line. All the x coordinates along that vertical line are all -2. They're all -2. Now, to save you some easy points on your test, make sure when you're doing your practice that every time you write the axis of symmetry, you don't forget the x equals piece. The axis of symmetry, we need the equation of that vertical line. If you just tell me the axis of symmetry is -2, that's not an equation. An equation needs an equals sign. We need the x equals piece. Those are some easy points that I see people lose on this particular test every year. So make sure you get that practice every time it's x equals. So now let's finish our graph. We know the slope of the right side is 1, so we go up 1, right 1. And then reflect those points over. And we get that nice symmetric V shape, and it's been moved to the left 2. So what happens to the graph when there's a number added inside the absolute value bars? The graph moves to the right, or excuse me, the left. The graph moves to the left. So it's kind of opposite of what you think it should be. When we see an addition sign, we think positive, and if we're thinking positive on a graph, we're thinking moving right. In the case of moving right, we actually subtracted inside the absolute value bars. So it's kind of an opposite of what you think it should be. When you subtract, your graph moves right. When you add, your graph moves to the left. So just be careful with that and make sure we get enough practice to know that it's always the opposite of what that sign actually is. And again, that's not just me telling you, here's what happens. We saw it, we graphed it. So make sure we practice it. All right, let's summarize, and then I want to put together what we did yesterday with what we're doing today. Looking at a graph that might reflect and move to the right, or might be compressed and move to the left. So let's just put together what we saw yesterday and what we just saw today. Then I want to do a few examples with you and then give you some time to practice. So first of all, this nice little breakdown right here. The first thing we see is that negative sign. The negative sign we saw yesterday, whenever there was a negative in front of the absolute value bars, our graph reflected. Now, if you need to make yourself a little note there that it flips, or if you need to put upside down, whatever you like. Come test time, though, I want us to get used to that vocab. It is reflected. It is reflected. The A piece that we saw yesterday, the A did several things for us. The A gave us the slope of the right. Gave us the slope of the right side. Larger than 1 our graph stretched. It got skinnier, more narrow. If you want to make that little note, you can. If that A value is between 0 and 1, we compressed. Now, when we're talking about the stretch and compression, I know a few of you doing the practice yesterday, you were getting a little caught up with looking at the negative sign and talking about the numbers bigger than 1, less than 1, things like that. When you're talking about a stretch or compression, we're going to ignore the negative sign. So if there's a negative sign there and we're looking at if our graph stretches or compresses, we're going to ignore the sign. If the number is bigger than 1, it's stretched. If the number is between 0 and 1, we're going to compress. Ignore the sign. But now, when we're talking slope, we need to include or keep that negative sign. We're going to include that negative. So I just want to make sure I clarified that from yesterday. That was a question I got from a few people. So when you're looking at the slope piece, if there's a negative, you include it. If you're looking to see if the graph stretches or compresses, ignore the negative sign if there's one there. Now, on to the piece that is new for us today, that idea of adding or subtracting inside of those parentheses, or inside the absolute value bars. If we had x minus a number, we saw the graph move right. And I'm just going to put h units. So whatever number h is, that's how far we went right. So we had x minus 3, the graph moved to the right 3. When we added, we had x plus 2. It moved to the left. Whatever number h is just a variable. That can be any number we want. So if it's x plus h, we really move to the left h units. So when we had x plus 2, the graph moved to the right 2. So this little summary piece right here, you might find super helpful while you're doing your practice. I know it's on the front side of this sheet right now. We're going to do some examples on the back. So you might have to flip back and forth, but then when you go to do your practice, you'll have this sheet that you can look at while you do your practice. So let's take a look. I just want to do a couple examples with you, walking through the expectations of how we pick out transformations, vertex, and things like that without having to go to the calculator. Now, if you want to get more practice with the calculator, feel free to enter these equations in also. You can pause this video at any time. So the first thing we want to pick out are transformations. Now, when it says transformations, those are things like reflection, stretch, compression, moving right, moving left. I'm going to start with, I always work my way left to right. The first thing I come across is a 1/2 in front of the absolute value bars. So that's the A value when we just summarized. That value is smaller than 1. So we're going to compress. We're going to have a compression. We're going to have a compression. That number is smaller than 1. And then inside the absolute value bars, we're adding 5. Remember, we have to think opposite. I know we see a plus 5, but it really goes to the left 5. And I just like to draw the little arrows so you know what part of the equation is causing that transformation to happen. From there, I'm able to pick out my vertex. I know my graph moves to the left 5. So if you need to plot that first, 1, 2, 3, 4, 5, and then write your vertex, You can. So if I move to the left 5, that vertex point is now at -5, 0. The slope of the right side, again, that's that a value, which would be our 1/2. The axis of symmetry cuts our graph in half. It goes right through that vertex point. Remember, x equals, it's a vertical line. I need the equation of that line. The x value for the axis of symmetry always matches the x value at the vertex. Those two will always be the same. They will always match the x value at the vertex and the x for your axis of symmetry. Now in order to graph, now we just use our slope. Your vertex is your starting point. We go up 1, right 2. Up 1, right 2. To get the left side, we just reflect those points over. Now we have our nice V-shaped graph. Make sure it's symmetric. Make sure you have all of your points lined up where they should be. Let's try something similar. There's just a couple more examples I want to do with you, helping you get used to picking out the transformations and vertex and things like that. Again, you are more than welcome. You can pause this video at any time. You can rewind this video. You can try things out on your calculator if you choose to. Let's start with the transformations. I like to work my way from left to right. So the first thing I see is a negative sign. The negative sign in front of the absolute value bars, we saw that yesterday. That's going to cause a reflection. The next thing I see is I'm subtracting 6 inside the absolute value bars. I know we see a minus there, but we have to think opposite. And we're really going to go to the right 6. You don't necessarily have to draw the arrows, so on your test or your practice, you don't have to draw the arrows. I'm doing that for the sake of our notes. So when you take a look back at your notes and you see reflection and right 6 written down, you know why we chose those things. What part of the equation tells you the graph does those things. For your vertex, for some of you, it's going to be easier to graph right 6 and then pick out the ordered pair. If you can pick out the ordered pair first, that is fine as well. So we're going to go to the right, 1, 2, 3, 4, 5, 6. That ordered pair is 6, 0. The slope of the right, that's going to be the number in front of the absolute value bars. I just see a negative sign there. Negative sign doesn't do me much good for my slope. I need to include the number with it. It is -1. And if you need to put it over 1 to help you graph, it's completely fine. The axis of symmetry, again, it goes right through that vertex point. Always x equals. The x equals part, I'm hoping we get enough practice in that come test time, it's just automatic. When you see that answer blank, you automatically write x equals. Now, what does x equal on that vertical line? It's going to equal 6. Remember, those two are going to match. For the slope, I know some of us still struggle a little bit with that negative slope. The -1 is going to cause me to go down 1. And then the +1 on the bottom is going to cause me to go right 1. So starting at my vertex, I go down 1, right 1, down 1, right 1. Reflect those points over. Now, if you want to pause here, you're controlling your own pace today. If you want to pause here, and try to pick out the transformations before I go through them, you sure can. If you just want to keep rolling and listen to my explanation, that is totally your choice as well. When I look at the transformations, I always start and work my way left to right. I know it's really hard. We see that -3, but when we're talking transformations, we actually need to split that into two pieces. The negative sign causes a reflection. The 3 causes my graph. It's bigger than 1. It's that A value without looking at the sign. It causes my graph to stretch. So be careful when there's a negative in front of the absolute value bars. The negative causes a reflection. Then I need to look at just the number piece by itself to see if it's going to stretch or compress. The last piece I need to look at, I have a +5. I know when we see positive, we're thinking that right is positive, but we need to think opposite coming out of those absolute value bars, and it really goes to the left 5. So that's this piece right here. So for my vertex, we need to go left 5. Some of you at this point, you might need to graph it before you write that ordered pair. That's okay. The slope of the right, that's the number in front of my absolute value bars. Remember, for the slope, we still include the -3. Axis of symmetry goes right through that vertex. It's a vertical line. Automatically, it's x equals. On that entire vertical line, what does x equal? X equals -5. Those two always match. Now I start at my vertex and I need to do my slope. The -3 is going to cause me to go down 3. +1 is going to go right 1. Down 1, 2, 3, right 1. 1, 2, 3, right 1. Reflect those points over the axis of symmetry. Now after you graph, and this is something we should have checked the last couple examples, make sure your graph fits the transformations you wrote. If we have a reflection, that means our graph should be opening down, and it does. If our graph, we say it's going to stretch, our graph should get skinnier, not wider, and it does. We have a skinnier, more narrow V shape. Lastly, we said the graph is going to go left 5, and there it is. That vertex point is over to the left 5. So after you graph, make sure your transformations match your graph. Your transformations help you describe what your graph should look like. So does your description actually match what you graphed? At this time, there are just 8 practice problems for you, just like yesterday. I have the answer key available for you to check. You should be able to get this finished before you leave today and have it checked also. Please make sure you are taking the time to check, just in case. Maybe we have our left and rights backwards. Maybe we have stretch and compression backwards. I can get a V-shaped graph that I think looks okay, and it might not be the right graph. So please make sure you are checking. Tomorrow we will move on and do our final transformations for this graph.